Hello everybody, welcome to the AquaStax Hour with me, Long Steve, at 2:58 PM on Thursday the 26th of January, 3 PM, a couple of minutes earlier than my scheduled start, but I'm here and ready to go. I'm trying desperately to stave off a cold at the moment, dosed up with the old day nurse or daytime cold tablets, so I've put my lapel mic on today, not the usual headset mic that I have, which picks up rather too many sounds. I might be snorting and sniffing a little bit. Also, you'll have to forgive me if I have to stop and blow my nose any second. Right, so at the end of last stream, I shall just briefly chat a little bit until somebody joins. Hopefully it won't be too long before some people pop into the chat room. So, the end of last stream, I had got to the point where, let's see, what was I doing? I was just fixed a few bugs. Yeah, that's right. I found a couple of bugs related to the index positions for block collision function and how it was returning the wrong things when the block was moving around the grid, and that was sometimes causing some glitches with the collision. So what am I doing? I'm going to start my gulp task, bring up Chrome, and one of the things I did was I'd got to the point where I kind of knew there was a problem with this function still, but I didn't want to spend ages and ages on the stream doing it, or finding out what the problem was. I said I'd do that after the stream finished and then show you all at the beginning of this stream. Turns out it only took me about 5 minutes to figure it out once the stream had ended. What am I looking for? Launchpad. We're going for Google Chrome. Here we go. Right. So, what was going wrong? Yeah, that's right. I'd broken the intersection function, which meant that the axis, not axis, it's slope collision bit, the bit that turns that block green, had gone wrong, so it wasn't working in this scenario. And it was because the block collision pieces were only 2x3 and not 3x3. So what I ended up doing was fiddling around with the code a little bit, and I discovered that inside this function, so what I did previously was I added this bit of line here. So what this does is, oh, hi, Colin Badmus. Hi, Colin, good to see you. Colin's Badmus, cool name. Anyway, I added this bit of line here, which determines if the block position isn't exactly on a grid boundary. It then adds 1 to the amount of times it loops through the horizontal tiles of the block in order to determine this particular width of cells that it collides with. But it wasn't doing it for the vertical, only doing it for the horizontal. So I added in this bit here, and then the other stream, last stream, I had fixed my tile bounds function, so the bottom and top ones were correct. So I duplicated the bottom and top loops, so it loops over the correct tiles, and now you can see it works. The actual complete number of overlapping cells is calculated properly, so that wherever the tile is, the cells that it overlaps are the ones that are going to be used for collision testing. And then you can see when it actually does collide with one of the other blocks, the collision function returns true or false, and it also returns the type of collision, which is determined by the color there. And the other thing I did was I added in a little function which I put into game.js, which allowed me to trigger the snapping of the block so that it's exactly on the grid boundaries. Here we go. So if I press the spacebar, then it actually positions the node based on the alignment with the grid. So if I hit the spacebar, what it will do is it will move itself to the bottom left-hand corner of the cell that it currently overlaps, like that. And when it does that, because the position of the block is exactly on a boundary, horizontal and vertically, of the grid, these particular functions here are false. So pos.x mod block size does in fact equal 0 when pos.x is a multiple of 50 because the block size is 50, and the same with y. So it doesn't add 1 on to the extra amount of cells it's checking for, because it knows that it's only actually going to need 2 by 2 in this instance. Whereas when it's not on a boundary, so there for example it's in the middle of the cell, it checks that one and that one, but then it adds 1 on because it knows it's going to overlap on the right hand edge and also on the bottom edge. So that all works. If I snap it back to the grid, then it drops back down to only needing the 2 by 2 collision detection. And when I do, so when I switch it back to the normal gameplay mode, so this is without the mouse controls, that means now that the block's falling, that the collision testing is only ever done on exactly the right number of cells. So the cells below, basically the cells that it overlaps. And as I rotate the block, you can see that the collision testing cells follow it properly. And the next one comes down. As it's moving left and right, it snaps into it completely from cell to cell. So it's never overlapping more than 2 cells. And the collision testing is exactly right. And I'm quite pleased because that was the last bit of the puzzle. I thought it would take me ages to figure it out, but it turns out it didn't. I just needed to utilize the functions I'd written last time correctly. Anyway, so collision testing is all good using my newest collision testing function, which is down here somewhere. It's collide objects. So this is the one. Oh, the last thing I did as well was I slightly tweaked the highlight. What was happening was this highlight, these red cells that are highlighting the areas of the grid that collision testing will occur on, was being triggered, it was being calculated in a couple of different places, which meant that where the collision testing function is used speculatively in a couple of places, so for example it's testing collision below the block constantly to see if it's going to stop, the cells that were being sort of highlighted weren't always the correct cells that showed exactly where the block was at any given point. But I fixed that by just moving the grid of the collision testing function. What did I call it? Highlight something or other. Highlight. Nope. I'll go back to SmartGit and remind myself. It was, here we are, highlight block cells. So that was kind of in line into one of the collision test functions, and I moved it out, and now it's called from within the game loop in a consistent place. Somewhere around here. There it is. Right. So I won't commit that yet. We'll carry on doing what I was going to do. Decide best place to handle collision and correct grid index values. So actually this bit, to investigate the correct grid index values, is now correct. Another thing I discovered the other day, of course, was if I break the debugger into this function, let's go into grid, we're already in there. The highlight grid index positions for block collision was returning far too many cells because it was getting duplicates. But now, hopefully, index should just be 4. Yes, it's only ever returning 4 now. It's returning the exact cells that are overlapping because it carefully works out the boundaries of the block, the cells that the block overlaps, and returns only those ones and doesn't have any fiddly bits in it anymore. So there's far less redundancy going on, or far less redundant calculations. And actually, I just remembered, so this particular function has been bugging me for a while, and there was an old to-do in here. Determine the overlapping cells properly. It doesn't quite work yet. Well, I'm pretty confident it actually does work now. So I'm just going to get rid of this. And then there was another fiddly bit here. Add 1 above just for the sake of it. Oh, hi, Infusey. Good to see you. Infusey. Cool name. So I get rid of these commented out bits that are now no longer relevant. Add 1 to the width and height to cover the block overlapping grid cells horizontally and vertically in the event the block isn't aligned exactly with the grid. Right. So now I can actually start to swap out some of my redundant collision testing functions, the old ones. So what did I have in here? I had, so collide block with grid bounds is still valid, because that's just testing the block against the edges of the grid. And collide block with grid data, that's probably the one I don't need to use anymore, and should be replaced with collide block. So we're going to figure out how to do that today. Let's see, how many times is this used? So it's only used once in this here. Okay, so it's not collide block, it's collide objects, that's the one I mean. Right. So in collide block, that's what's called inside a loop out of the game in several places. Yeah, there's several places it uses this. So collide block is my kind of overarching call this function if you want to test for a collision function. And it calls the subfunctions collide block with grid bounds and collide block with grid data. Right. But it's this one I want to get rid of, because collide block with grid data should now be replaced with collide objects. So let's see how we're calling them and what we can do with them. So this call test if a given block at the new position will collide with the tile blocks already in the grid. So collide block with grid data. So we test for various things. We call get index positions, we loop over it and do various things. Now the logic for that I had written in here in my mouse testing code. Here we are. So figure out why the collision seems to be off by 1 on the vertical. Well, that's actually not the case anymore, I know that. So this is the loop that does the collision testing for the currently falling block. And it basically tests each of the cells within the block against the corresponding positions that that cell overlaps the grid. Does it even need to do that? I would think that actually that loop is redundant now as well. In fact, I might just go back to my mouse testing code and test this out. So that's actually, so we've got moving object self.block, and we get the cells, and then we loop over each of those, and then we create a temporary block in that position. That's right, because temp block, so sorry, this one, get grid index positions for block collisions. So this function was only really designed for a specific individual grid cell, I think. Get grid, oh no, it does. No, it only tests get grid index positions for block collisions. It's my terminology was a little bit woolly, and I think block collision is actually only individual grid cells. Right. Oh, hi Colin. Collins. I'm not sure if you're Colin or Collins, but good to see you. Right. Let's just remind me of what this does. So it loops over tile bounds. Push the index directly. Yeah, maybe it does actually loop over blocks. Let's just try this. I'm going to remove this loop. So T. Remove that loop. And then we work out cell as the. Work out positions particularly. And he works out new index, doesn't it? Bottom left. Yeah, it's not actually taken into account the actual block position, is it? I don't think. See, the cell position is moving cell plus moving position, so it's the actual position of the block, and then for each cell within that block it works out its position, and then it creates a temporary block using the particular cell tile, which is the square or the triangle bit, and then passes that in. I'm pretty certain if I do that it won't work. I'll leave it like it is, but this particular loop is what I want to call within my function down here. Collide block with grid data. So what I can probably do is actually re-implement collide block with grid data. Square, check for triangle overlap, so it returns 99 for a collision and 0 for no collision. Right. I'm going to be bold and get rid of this completely and re-implement it using this bit of logic here. This is the bit of logic that does the rendering if collisions occur. Right. So it's block dot get tile cells. Yep. Get object data. Get position. But the moving pos. What we're actually going to want to do is a new pos, I think, here. Oh, hi, welcome. Live Coding TV support. Do I care about the rotation? I wonder if I should. I never regarded this game as a puzzle game, to be honest. Fair enough. Yeah, it was more of just a kind of a progress through the levels. You had to solve each level in order to complete it. Did you actually play it when it was originally available on mobile phones? Okay. Do I want get position or do I want how many levels am I building for it? Well, the original game had 50 levels, 5 different sort of areas. I think there was the mountain area and the snow area and so on, 10 levels each. And then it had 5 infinite levels, which just reused the same scene, but you could basically move the blocks up and up until the water topped you out, or water drowned all of your gumblers. Let's see. Someone's just joined. Yana Seattle. Oh, good to see you. Oh, and my hat flashed. Excellent. I'm glad the hat flashed. One of the things I've been doing over the last few days is building my hat. As you can see in the corner of the screen there, I should point at it. I'm not actually wearing it at the moment because it's only held together by bits of tape. I've got an RGB LED strip wrapped around it, and you can see that it will react when people come and do things. So if someone follows me, if you follow me on Live Coding TV, you'll get a reaction from the hat. Hopefully people who join and leave should get reactions as well. And you can control the hat from the chat. And let's do something like, you type in hat, exclamation mark hat, and then let's do Cylon. Hopefully the hat will react. Yes, and it moves this little red symbol around the hat. And there are a couple of other things you can do as well. If I type help, Tim, my bot, reports the commands you can use. So there's color, Cylon, rainbow, pulse, and clear. I'm unsure as to whether or not the hat control will be always available from the chat. We'll see if anybody abuses it. It's just a setup that I've got to test things out, because this is the first time I've got it. I'm currently in the process of trying to fix the blocks, fix the LEDs and the strip properly to the hat so I can actually wear it on my head. It's wireless as well. The controller is one of these things. It's called a particle core. Particle used to be called Spark, and they ran a Kickstarter a couple of years ago to produce these little controllers, microcontrollers, Arduino compatible, but with extra features like Wi-Fi and things built in. And they have their own cloud environment, which means that these things are constantly connected, so you can send commands to them or receive data from them from cloud code, which is really good. So my chatbot Tim is hooked up to this hat directly. Let's do something else. Let's do a color, and you can actually pass it RGB values. So color, hat color 0x. Let's do a yellow. So that's FF00. And yep, there it goes. It's just cycled up to yellow, and it'll stay that way until someone changes it. So if you want to change the color of the hat, go ahead and type something in. See what it does. So where was I? Completely sidetracked by my hat. I'm going to just leave those as they are for the minute, and then I reckon I can just return collision at the bottom of that, can't I? Let's see what happens. Config, I can go back to false. So I expect in most cases this is just going to color block with grid data. It's not equal 0, it's just going to return positive value. I don't think I use any of the actual, it does use claims left and right boundary collision, but I don't know if that's hooked into anywhere yet. Let's just try it and see what's going on. Okay, doesn't work. Cannot read property set position of undefined. Of course, I started using the temp block business, so I just want temp block. Actually, I'm going to put that in. I don't want to allocate a block every time a function is called for collision testing, so I'm going to put it in there. It's just self. Right, the block's coming down. Okay, so that still triggers. Will this land on top successfully? It did, yes. That one should land there. Now, the test for this particular function is whether or not two opposing triangles, oh, that was interesting. So these ones should collide. Oh no, they fell through. Oh well, I was expecting that collision to trigger something. And also the fast moving isn't stopping quickly enough yet. But that's okay, we'll start working on this and figure out what's going on. I think it's because the new pos and new rot isn't tested. What I actually want to do is moving pos get. I don't want to do block to get position. I want to do block dot. It's just a new pos, isn't it? Really. But how does the rotation get taken into account? Block dot get tile cells. I think that's probably return a list of tile cells with position offsets. Does that take into account the rotation? It does, doesn't it? Include empty. I might have to include rotation on that as well, and then do if type of rotation. So in here, new rot. Block.get object data, what does that do? Yeah, this takes into account self.rotation as well, doesn't it? I saw the hat change colour there, but I didn't. Must be imagining it. Right, so let's just see what that does. Okay, so that's now taken into account the potential followers just have occurred. Eugene Esker, good to see you. And my hat did a rainbow cycle-y type thing when you arrived. Recognized it. Excellent. It's now gone silent. I wonder what, I can't remember what I configured the hat to do when a new follower arrives. I think it was probably just pulse white. We can do the same thing again. Hat, pulse. There we go, it's pulsing white. Maybe I should use a rainbow color. It's difficult to see the colors, they're a bit bright on the screen in the corner. I'm going to have to tune them when I've actually got the hat on my head. Anyway, that's working now. Now I can see if I can get one of these to overlap. Oh, that's not going to do it, is it? That one. Yes, it gets stuck there. So let's put that there. So now, what was happening before, because my collision testing was naive, these two triangles, this one here and this blue one, would go through each other, but now they're successfully colliding. Excellent. And they seem to be colliding fairly well at speed as well. This is me dropping the block down with a fast drop. Let's reset that. Yeah, so they would do it. Dink. They won't go through each other. Right. As long as the fast drop doesn't move the block however many spaces it needs to jump through a triangle in one game tick, then that collision should always work now. And I should be able to tell whether or not it's a collision with a slope or an axis. So the next thing to do is actually to start getting the sliding going on. Right. Oh, it's so much fun now. Yeah, seems to be still working okay. Triangle tris, indeed. Tetris with triangles. I was explaining this in the last stream. The good thing about using these triangles is, although it's quite complicated in the code, it means I can create totally arbitrary shaped blocks and move them around and drop them, which is what will happen later on in the game when clusters of colored triangles the same color merge together. And then when we break the blocks underneath them, they'll all collapse. Anyway, so like, for example, I could put that pointy block there and it would break the pebble one underneath. Right, so let's see if I can respond let's just get the block collision type, the axis or the slope collision worked out properly, which it should do now. So collide block with grid bounds, that should always return 1 or -1. And what did I do with the axis collision? Where were they defined? I can't remember now. Must be in here. Here we go. So this was me setting a couple of bits in the collision response code to do with whether or not the slope or the axis was collided against. Let's see if I can put some kind of indicator back in that allows me to see whether or not what collision has occurred. Highlight block cells. On that. Actually, they're shifted up by 8 or 9. That's always going to set the bits above the first byte. So -1 though is going to not be a good thing to return. Where's my functions that return somewhere it returned -1, didn't it? Yeah, I think that's the right boundary collision. That's probably coming out of collide block with grid bounds. Yeah, -1's a bad thing to return. I might have to change that. Wonder if it's used anywhere. It probably is. Search for -1. Yeah, there we go. Collision 1 or -1. That was my bit of code that says whether or not it's collided with the boundaries. Excuse me, I keep burping a little bit. Just as I said earlier, I'm trying to stave off a cold. It's rather, I'm dosed up with tablets and things. Just going to play with that again. Let's have pink. There goes. Excellent. Right. Anyone can do that, by the way. Type in hat commands, see what happens. Maybe I should just do 1, 2, and 3. I suspect it's only there that it's used. Change it to 3 for bottom. So 1, 2, 3. Yay! Hat rainbow. I don't know how good that shows up on the screen, but it's cycling around rainbow colors. Ooh, someone else has just joined. Welcome, Ju. Good to see you. Yeah, I'm pretty pleased with the hat actually. It works really well, and being completely wireless, I can actually run it off of. It's currently plugged into a power pack, but it's cool. Will the rating affect the hat? No, I don't think I hooked it into the rating, but I should do, of course. I'll worry about that another day. The power supply for it is currently just a wall socket mobile phone power supply, but you can actually power it off of one of those USB power bricks you get for recharging your mobile phone that you carry around with you. So you can charge the power brick up, then you carry it around until you need to give extra power to your phone. And I've got a little USB cable, and that will run off that. And some of the more modern ones can push out 2 amps or even 2.4 amps at 5 volts, enough to power an iPad, and that will run the LED strip really well. So I could actually have it completely wire-free once I've got that and the LED strip sewn together. That's the hard bit. I can do the electronics, but the sewing, I've no idea how to do sewing. Anyway, let's try not to get confused, because I want to go back to here and do this if it's 1 or 2, and then collision is 0. Fine. Oh, hi Denver Cowboy, good to see you. Am I using that collision anywhere else? I bet I am. I can probably get rid of most of this code as well now. It's mouse move testing, because I've just borrowed that and put it somewhere else. Although, if I do this, if I put this down somewhere in the collision, in the normal path, let's say at the bottom here. So we're working out a collision there, bunch of tests, highlight block cells, collide block, this is if we're fast dropping, rotate the block through 90 degrees. If I just put it down here, moving pause, is that what's moving pause? I want self.block.getPosition. Okay. So hopefully the moving block do that. Will it flash, I wonder, when the collision occurs? No, it's not. I could just do a bit of text. But let's see. What I want to do, first thing I want to do is make sure that the collisions that are being reported are the correct ones. Then I'm going to work out the direction of the slope of a slope collision pointing down to the bottom left or the bottom right. Then I can start worrying about sliding the blocks when that slope collision occurs. So let's continue with what we're doing up here. It's kind of at the point where the block is 0, isn't it, that I want. It's here. So this is collide block. So this is the bit. Tell you what I'm going to do. I'm actually going to get rid of this mouse move block function now, because that was designed purely for testing out all this collision code, which is now integrated into the normal loop of the game. So if not mouse move block, so that's there. Let's see, if mouse move block, what does that do? That's inserting things into the grid for some reason. During the constructor, that was me setting 2 blocks to start with. This is visualize the collisions with a draw node. Let's see, let's go back for search that again. If so this is the mouse listener functions for moving around. I'm going to get rid of these completely because they're in source control. I can find them again if I want to. Oh, somebody's joined. Hat cycles. And is Tim going to announce the new follower or the new person joining? Yeah. There's a bit of a delay. Definitely. There we go. My big friend. I wonder if Apostrov. To tell you what it is. So I've got 2 windows here. I've got this one, which is showing my web browser directly into livecoding.tv or liveedu.tv, and it's slightly ahead of my chat window here. But also my bot Tim only decides to show greetings for people once they hang around in the chat room for more than a couple of seconds, which means if people are just spinning by the website and pop in for a couple of seconds, like somebody called Apostrov did just then they won't get their name flashed up. But my big friend, you cause that to flash. Right. I was getting rid of this code, wasn't I? I don't need mouse move block anymore. So it's so tempting sometimes to leave. Opted out too fast. Yeah, you did. It's so tempting to leave old code in, but I'm going to get rid of it for now. Mouse press, mouse move, blah blah blah. Ditch all that. Hopefully it won't break anything too badly. Update mouse event, set block position. No, leave that. So if the falling block cannot move down, lock it in place. So this is probably where we could do a highlight thing instead, isn't it, actually? So let's do a highlight. Oh, somebody else came and went. Well, live coding TV support again, cool. Check out the live edu streamer Bible. Okay, I'll do that somewhere. Highlight the collision that just occurred. I'll jump back to this point in a few seconds. Collision testing code. So this is all the code that I just copied and pasted and moved out. Let's make sure I don't ditch too much of it. There. Apostrophe came back, hello. And he stayed long enough to get your icon in the corner. Right. Well done. So I think that's all of my instances of mouse move block. Oh no, I want that. Oh, it's just there. So move a block by delta x delta y, return false if the block is not actually moved. Oh yeah, that was only right. I'll probably find in a couple of weeks' time I'll end up putting almost exactly the same set of code back in again, but at least while I'm there, or while it's not in use, it's not cluttering up the code base. So let's just see, what will that do? That should actually collide. It does, excellent. And this one should collide as well. Before this would have not. I wonder. Let's just see if I can poke that in there. Oh no, it doesn't work. So there's a few more special cases to sort out. As this block slides down here, I'm holding the arrow key to the left, and it really wants to just pop in, but it doesn't do that at the moment. So there's definitely some special case code I need to put in. I remember doing that last time round, years ago. So for example, this one here, you want to be able to slot this in to make up a solid thing, but it's not doing it. Probably because it won't, it doesn't overlap the exact horizontal grid boundaries, so it's never actually on the point where it can slot in exactly while it's moving down. Anyway, I can fix that later. So that's still going. Now we want to go up and put in some of my highlight collision. Let's make a new function for this. Let's do a where shall I put it? I suppose I can put it there for now. So it's going to be on the moving block for now. We might pass in some parameters to it in a minute. Actually, let's pass in the collision. Ooh. Currently 1665 lines of code, absolutely. So according to Live Coding TV here, I've been streaming for 37 hours and 12 minutes, which is still not even a working week, really. I mean, if you were working, you probably do 37.5 hours a week, maybe 40 hours, depending on your daily time. So I'm just about hitting a working week had I spent full working time on this project. But as it is, I've been doing it sort of 2 hours, 2.5 hours a week for the last couple of months now. But I think, had I been starting a game from scratch or writing something, the point I'm at now is pretty good for a week's worth of work. So, collision test. Oh, I need the self equals this. Right. If grid.collide, so here we go. So it's this bit here, isn't it? Collision zero collision equals self.grid collide grid block. I must keep my live coding stopped showing the current stream length. Ah, it was near the donate button. Was it indeed? I can't even see the donate button. Maybe it's because I can't. Maybe because I'm logged in as myself. Yeah, I'm just looking at the total time that appears at the bottom of my channel page. They're going to do a whole load of changes recently, actually, or a whole load of changes soon. If you read the newsletter, there's various user interface and system changes to do with being able to create projects rather than just have a channel. That'd be really good, because it means as a streamer I could have multiple projects, whereas at the moment if I switch between projects you have to do a whole load of retexting of all of the channel page and all that sort of stuff. It's a bit of a pain. I'm wondering if I should stream on Twitch as well, although I shouldn't say that if Live Coding TV support is watching. But there's a couple of services you can use, like I think it's restream.net. Plus I can do it myself by just using a instance of Nginx attached to an Amazon Web Service or something to forward the stream onto multiple places. But I think before I do that, I would like to get my bot talking to Twitch TV's chat as well, which is certainly possible because they use I think they use IRC, whereas Live Coding uses Jabber, but libraries can talk to both things at once. Something to try one day, I think. There's that I'm streaming here only. Sorry, I'm looking at your text before it appears on the screen here. Streaming only Twitch have most gamers community. Yeah, I've noticed that development streamers on Twitch are few and far between, but that means there's an opportunity for doing it well and not being within a crowded marketplace. There's a couple of guys who are quite good on there. One, I can't remember his name, Adam somebody, streaming his game Botland, gave me the idea for the hat with the RGB lights and things. So there are one or two streamers on Twitch doing the creative section, programming and game dev. Anyway, chatting away here. Highlight collision, so self.highlight collision. I wonder if that's going to work. It should be just use self.block. Self.block, yep, block size. So it puts and it sets the collision. Right, okay. So let's just see what's going on. So let's move it down. Bink. So it don't know if it did it or not. Let's debug this and see what's going on. So the function is 177 in game.js. So it should be coming in here at the point it collides. There it is, right? Collision 256. Okay. Oh, where did that go? Did I miss something? Oh, got the stack disappeared on me there. Let's go in. F11. Right. F10. If collision does not equal 0, if collision and axis collision. Yep, axis collision. Self.collision. Okay, collision test. Draw rect, yep. Then we set the position to the position of the block that's just been falling down. Then we set it visible, but I can't see it. I wonder if it needs collision test. Where is it added to? So it's draw node and it's added to the game panel. Yeah, that should be fine. 100, that should be the right Z order, the right priority. Why can't I see it? Draw rect, yeah, 0, 0, block size. So it's invisible to start with, that's fine. If I just do that, it should appear in the bottom corner of the screen when the game starts. Yeah, there it is. Oh, it disappeared. Okay. Collision is 3. Let's see, where's it moving? Oh, moving it to Self.collision test. Where's the position now then? Ooh, who did that just arrive? MDemon. Good to see you. Position. P. LMNO. Oh, I can't find position. Is it underscore position? There it is. So it's 3. Oh, yeah, that's it's off the screen. Ah, have I done it after new block? And it's moved it. It's drawn the rectangle in the position that the new block has been initialized to, hasn't it? There we go. What I need to do is do it in here. Highlight the collision that just occurred. There's no longer a to do because we're actually doing it. And then allocate a new block for falling. That was a pretty silly schoolboy error. There it is. So that green means, I forget whether it means slope or axis collision. So that's purple. Yeah, purple's an axis collision, so that's the flat. What this means is that anytime a flat collision occurs, then you don't need to slide or brake. But if a slope collision, slope collision, so it could be like that, you have to do some checking then for either braking the blocks or sliding. In fact, in this case, so if I do that block should slide off to the right when it lands, and hopefully the collision indicator will go green. It does, and that's then after the collision indicator has gone green. Now there's another couple of things that we can test for here. I think that simply the fact that the collision indicator is green doesn't necessarily mean that the slope that it has to slide, because there are two scenarios that can occur. So where we've got a nice long slope like this, let's put that one there for now. And then if I build something there, let's do that. So what happens when I do that? See, that won't slide, and it's probably only going to indicate slope collisions. Yes, it's gone green, but it shouldn't slide. So I've got to watch out for that. There's another thing to watch out for as well, and that's there. I think that's only going to give me a slope collision. Yep, gone green, but of course that's stuck. So there's various other extra testing things that have to occur. And there was, what else was I going to decide on? Here we go. Yes, so this again similar slope collision, but it shouldn't slide. And there's definitely another scenario where you want the slope collision. I think it's possibly that. So that should give me both a slope collision for the pointy bit and an axis collision for the flat bit that lands on the square block as it lands. So let's see what it gives me. It gives me, in fact, in that case, it should give me both because they're bit flags within the collision integer. Similarly with this one, but the test for the highlight is actually if it's axis collision first, else. So actually, if both those bits are set, then it's only ever going to come down this path. I should actually do a third one, shouldn't I, for both the set? But either way, that's giving me all the information I need to start going forwards now. So what do I want to do? I want to work out the direction of slope for a start. So if we have a slope collision, the little indicator goes green like there, then we want to work out the direction of slope. That's the first step towards getting sliding going on. Right. Oh, I could play this for ages now. Oh, there's so many points I could take the code in now. I could carry on doing this collision and sliding and things. I could fix the little glitches like the slotting into place there. If I put that upright, see, it'd be nice if that could slot into place, but it wouldn't. Then there's also, well, that slot. Oh, actually, it might have slotted if I was careful. There's also the clustering of blocks that are the same color. That's a thing to start looking at doing. There's also a whole bunch of things. Will this? No, it didn't work. There was something I was going to just check. There's all, oh, yes, that was it. I mentioned earlier, or in the previous stream, that I could actually deploy this code now to AquaStax.com and let people start playing it, which might be a good thing to do sooner rather than later, because there's almost a game here now. Let's see. Here we go. So if I should be able to move this to the right. There we go. Yep, it just slotted in just at the right moment. Well, actually, it was just after the right moment because it. Will this one slide? No, it won't. Anyway, so I can deploy it. I can do a bunch of code for deploying it. I can look at the various bits, but I think we'll carry on with the sliding in the direction to start with. I've only got 5 minutes left before the end of the stream today, but what I'll do is I won't commit the code yet. I'll dive in and see how far we can get. So we know at this point, highlight the collision that has just occurred. So this is test to see if the falling block can move down. And if it can't, then we do stuff. And so it's kind of this point here. Highlight the collision that just occurred. Yep, new random block. What do I want to call it? I want a bunch of test, maybe a test function. Let's call it test for sliding. It's probably not going to be necessary to pass the collision function, the collision value in, because I'm going to work out a bunch of stuff again, aren't I? I'll pass it in for now. Test for sliding. So, and if collision, if the falling block cannot move down, lock it in place. But if self.test for sliding, then what do I do here? We can mark the block as sliding and then continue the game loop. So that what we should probably do is mark it as a new sort of game state or change the state of the block. And then in here, handle the sliding, because the sliding is not just moving the block down like this bit of code here, I think, dy, fast drop, or not fast drop. That's the bit that moves it down. It's also moving it to the side, isn't it? Test to see if the falling block can move down. So I should probably flag something in the block that says test for sliding. Probably not going to get very far today. I'm going to need to think about this as I go. So if test for sliding, actually, so let's do a test to see if the falling block can move down. Test to see if the falling block can move sideways. So that's dx gets set if the left or right buttons are pressed. Yeah, left or right. So dx is 0 if left or right isn't pressed. Fast drop sets dy. So at this point, dx or dy is where the user wants to move the block to. And there it is, actually moving it. So what we want to do is we want something that says if the block is sliding. So I mean, I could just set a block dot is sliding. If block dot is sliding, then Yeah, this is probably the best place for doing it, because if you're sliding, you still want to be able to make it go fast. While sliding, you still want to be able to move it to the right, but obviously not to the, or move it away from the sliding slope if possible, but not into it. So as long as there's no collision going to occur, we get to this point. If block dot is sliding, handle the sliding block. So we're going to add something to dx if sliding will occur, as long as dx is 0, because if dx is not 0, then the user has moved it away somewhere. So if sliding block and dx is 0, right, we'll work out the direction of slide later. Handle sliding block. Just give myself a reminder that I'm working on this bit of code. And then, based on the direction of slide, add a value to dx. So we'll do that in a bit. Test to see if the block can move down. So that's kind of different. So that's going to be in the else section, isn't it? Test to see if the block can move down. I'm going to mention move straight down. So yeah, we're not adding anything to dx at this point. We're just testing the collide block after adding the y to it. Then we test for sliding. Should I be testing for sliding? I could test for sliding each time. I don't know, we'll have to see how I implement test for sliding yet. If test for sliding self.block, then what this will do is set it true. So if it tests for sliding, and if test for sliding returns false, then we're going to have to do the block is stuck bit, aren't we? So falling block cannot move down or slide. Lock it in place, highlight the collision that just occurred. Actually, we don't care about that at the moment. I might put that back up there. Allocate a new block. Right. Otherwise, move the block. Yep. So highlight collision, test for sliding. Okay. Return false. If no sliding can occur, so let's do self.block collision, self.block. I'm going to move this above the highlight function because it's a bit closer to where I'm working. Block collision, right. Return true if the block will slide. In this case, also set block dot, what do I call it? Block dot is sliding, and block dot slide direction. Yep, return false if no sliding can occur. So if we just do return false for now, and what I should also, I mean, I don't have to actually set block dot is sliding, but we could do block dot is sliding equal false. It'd be undefined to start with. So let's just check that's not broken anything. Yep, got to fix up some syntax. Block is not defined, game.js 168. Self.block. Okay, so because test for sliding is always going to return false, then no sliding will occur and it won't affect anything at the moment. Let's just do that. Yep. Right. Handle moving the block. That's all right. Okay, can't think of anything else that I need to worry about at the moment. It's probably a good point to stop. I'm not going to actually start doing the sliding. I mean, let's just have a quick think while it's still fresh in my brain, because come next Tuesday. So my next stream will be Tuesday evening at 8 PM UK time. That's when I do it regularly, twice a week. I'll end up looking at this sliding code, and we'll probably. Actually, I ripped out a load of code earlier, didn't I? Which might be of benefit to us. Let me just dive into SmartGit here. If I look in grid, pardon me, gosh, am I belching a little bit today? It's terrible. I use my switch to my lapel mic today rather than use the one that's attached to my face, the headset mic, just because it picks up so many small subtleties in my voice and speech. And also I'm sipping tea more because my mouth is getting dry due to trying to stave off a cold. Okay, what I was going to check was the function I ripped out. Was it collide? Was it that one? Yeah. Check for cell triangle overlap. So it's these triangle types. What I want to do is, if this axis collision is going to occur, sorry, if the slope collision has occurred, it would be good to mark where it occurs actually, because obviously that's going to be the point where I want to start looking at what the two overlapping objects were. So for example here, that will be on the bottom of the grid anyway. So there, if I drop that down. So if I drop this down, the actual collision point, what I want to be able to do is remember the fact that I've got a one sort of triangle there, whatever type that is, and another one there, whatever type that is. If I look in block down the bottom, it should tell me. Here we go. So we had a type 2 and a type 4. So when a type 2 and a type 4 meet and cause the collision, then we know that the slope direction is going to be down and to the left, so negative in the x value. So my slope direction could be -1 in that case. And then if it's the other way around, it's going to be positive. So if these two meet, then I know that I've got a 1 and a 3 meeting, and then the slope's going to be positive in that I can add some value to the x position of the block in order to make it slide down the slope. I mean, when all the slopes are going to be 45-degree angles, which is really handy because I never have to work out any complicated maths too much. It's always just going to be 45 degrees. Ooh, somebody's just arrived. Hi, live streaming Ryan, good to see you. I quite like the hat flashing in my view. If I'm wearing the hat, I won't be able to see what's going on with it. So it'll probably be a lot more useful for people watching. At the moment, it's subtly hidden out of the way. Anyway, so yeah, so I've got some. So I'm going to have to look at testing what types of triangles land on each other, and also the point of collision. Now, the point of collision is going to be somewhere down here. This collide block with grid data. So collide objects. So I'm looping over. Block. This is all my old triangle code. Are we down here at some point? Do we actually have positions? I'm thinking I might either do it at the higher level, so within inside that loop here, collide block with grid data. Somewhere here, we've definitely got references to the actual grid position and cell position. So the cell, I think, is the moving object. Yep. The grid is the point in the grid where it's going to occur. So I should definitely flag that somehow. I wonder how I do that. I might have to augment the block. So this is where we're looping over all the individual cells within a block. Definitely want to augment the block with data about the collision when it occurs, so that I can then use it back here to work out things. Okay, that's probably a good point to stop. I think I might just make a comment about that in here. So collision in here. I should probably also change a couple of my function parameters to be things like cell rather than block. This collide block function is actually collide cell, with a cell being a small 50 by 50 square cell. Block is a collection of cells that make up a moving object. Yeah, I'm going to have to think about that, because I found myself earlier getting slightly confused by the difference between this function only taking an individual small shaped block, which is why I have to do a temp block that's only one cell size, one cell big. And in fact, I borrow the defined block number 3, which is the 1 by 1 small square. Yeah, I'm going to have to make a note of that, and maybe think carefully about renaming some of my parameters or functions so that I know when they operate on cells or blocks. Also one called collide object, that's a throwover from the old bit of code I borrowed from to name it. So I'm going to have to think about that carefully. That'll be so. Now I've done some refactoring already. I can now start saying I'll refactor that later. So actually, let's make a note of that to investigate. So that's good. To refactor, decide on the best place to handle collision detection. I'm okay at the moment. There's a combination of collision detection between the grid and the block, so I'm not worrying too much about that at the minute. To refactor, rename block functions, block or grid functions that only operate on single cells. That is the 50 by 50 grid cell sized elements. Yes. Things hopefully fixed. Dropping blocks sometimes stick when they're not supposed to. 2 by 2 blocks can sometimes fall into the bottom of the grid. Am I confident enough to remove that? Yeah, I think I am. What date are we? 26. And I don't really need this anymore at the moment. I'm going to get rid of that. This seems to be, I've called it refactor.txt. I should refactor it and change it into something else and call it ongoing note.txt or something like that. But ongoing block slope collision and handling, or slope handling. Ooh. Slope handling and collision. Right, we'll leave it as refactor.txt for now. And back to here, when the collision occurs, we want to augment the input block object with data about where the collision occurred and what type it is. So I think I've got enough comments for myself to carry on where I started. Carry on Thursday afternoon. No, Thursday. No, what am I talking about? It's Thursday afternoon today. Tuesday evening. That's when I'm going to do it. Return to the block will slide in this case. Also set block.sliding and block duration true. False if no nothing can occur. Slide direction. Yep. Implement this properly. Right. I think that's good. I will commit that and then call it a day. Config, can we remove that? Refactor block. Right. Commit. What do we do today? I've completely forgotten. Remove the mouse test code. It was mouse move block, wasn't it? Mouse move block. Oh, I know what we did. Integrate the latest full triangle test collision routine into the falling block test. Remove the old redundant test code. That was too naive. It didn't work very well. Remove the mouse block code and started the framework code for slope collision testing and block sliding. Is that going to go? Yes, it's gone. Right, so that's all in the source code. Let's somebody gave me a rating earlier. Yes, 100%. Fantastic. Appreciate that. Let's give the old hat another go. Let's give it a Cylon of red. There we go. Oh no, blue. RGB. I'm trying to think of myself as a hat. And what else can I do with that? I can't remember what the other commands were. Help. Hat. Pulse. Color. Oh, I can just actually give it any old color you like. Color. Ooh, rating's gone down. Thanks very much. Sorry, I'm distracting myself. So RGB. So it's I don't know. Let's do 88. Some kind of like grey color. What does that do? Yeah, well, it's actually white, grey white. And then we can do hat color. Let's have something a bit more orangey. Rare RGB 88 FF. There we go. Yeah, a bit more blue. Yeah, not sure the command works. What were you doing? Were you trying some color there? If I was fiddling around with it as well, then it doesn't stack up commands or queue them if something's going on with a hat in the wrong place. Sorry, if the hat's being operated on by two people at once, it'll all go horribly wrong. Yeah, rate 50 worked okay. The rating overrides your previous rating, so it averages out. So if everybody gives me a different rating, then I get the average. And if you do a rating twice or more than once, then that overrides the previous rating you gave me. Anyway, one last hat command. Hat rainbow. Yeah, there it goes. And that'll do for today. I shall see you on Tuesday evening. Thanks very much for watching, especially Collins and Yana Seattle. You've been around for quite a while now. Much appreciated. I was talking about the command you were testing. Okay, you're not seeing it. It may be the camera doesn't pick up the color changes very well, depending on how light or dark they are. But it's definitely working at the moment. I'm definitely getting hat things going on. Big hat. Cylon. Let's just go for Cylon again. I think it picks red. Yeah, there it goes. Actually, I seem to remember the color command will pick a random color if you don't specify one. Yeah, got a random blue. Another one goes yellow. Yeah, it just picks a random color. Anyway, I shall get to some sewing in the next few days and install the LED lights properly in the hat and then wear it on my head. And then I shall see you guys and girls soon. Thanks very much indeed for watching. let's go back to my splash screen and I'll see you soon.